So 8255 is a basically a programmable peripheral device. Okay. So now in this particular peripheral device, why it is used? So it is basically used for extending the I/O capabilities. Okay, so it's basically used for I/O capabilities, extending the I/O capabilities. With what it is going to provide the I/O capabilities with microprocessor. So with microprocessor or microcontroller. So with the microprocessor or MUPI or MUSI, that is microprocessor or microcontroller. So it is going to provide the I/O capabilities. So now if you take the most of the processor or controllers, if you take, so they are going to provide only limited I/O. So if you take your pin diagram of any of the processor or any of the microcontroller, so they are going to provide you minimum set of I/O ports and data lines, okay, to communicate with the outside world. Now for this one to minimize, so that more number of hardware components has to be connected, so we are going to make use of the programmable peripheral devices. Okay, so this PPI device expands the capabilities of processor or controller. So this particular PPI which you are going to use is going to provide you the IO capabilities for it's going to provide the IO capabilities for processor and controller. So now, so your 8255 if we take, so your 8255 is your 8255 is a PPI device for is a programmable peripheral device for PPI device for 8-bit microcontroller. So it is a PPI device for 8-bit processor or controller. What they are going to tell. So even if it is above this particular 8-bit, it is can be used. Normally they are going to use for your 8086 microprocessor, which is a 16-bit microprocessor. Okay, so 8255 programmable peripheral devices is most commonly used in your 16-bit microprocessor, which is 8086. So to communicate with the outside world. So when you want to make an interfacing with the outside world, it's going to be used. So basically what your 8255 consists of. Okay, if you take this particular block diagram here, okay. So now, so if you take the block diagram, so the internal block diagram of F255, so it is going to have the different blocks. So what are the different blocks it is going to have? So the different blocks which is going to be had is one is your data bus buffer. It's going to have where you are going to have the connect to the different data bus, and it is going to have the read write control logic. So it's going to have. So next once you have the read write logic, so it's going to have the group A controller and group B controller. So depending upon the type of the group, so it's going to control that particular ports. Okay. So basically your 8255 is going to support three different ports. So that is port A, port B, and port C. So if you take the port A, port B, all these ports are of 8-bit pin. So all these ports are of 8-bit pin. As the naming conventions indicates, you can see it here. So it is going to have the group A controller. So this at the right hand side, you can see it here. These are nothing but the ports. So that is group A port, group A port, group A port A, which is of 8-bit. So this 8, 4, 4, and 8, which will be there under the port B, specifies that how many bits it is going to support. So it is going to tell you that so how many bits it is going to support. Okay. So now when you are going to have the group A controller, so here if you take the group A control, so which are going to have, so here you can see here group A port A is of 8-bit. So next, so if you take group A port C upper, it's of 4-bit, and group B port C lower, it is of 4-bit, and group B port B of 8-bit. Now next comes the question, how I have to make use of this particular ports. So now how I have to configure my 8255 to configure to make my port to be used when port A is used, when port B is used, or when port C is used. Okay, so that depends upon what is my next question. Okay, so which you are going to have. So now this particular program is not as part of your syllabus. Okay, so this is only for your understanding purpose. What I have been showing you. That's it, nothing else. So, but this particular block diagram is not part as our syllabus. So now when it comes to port B, so when you are going to have the port B, so you take the block diagram, so if you take the port address, so what I need to do? So when the which port will be selected, which address the port is located. So that depends upon the pin number A0 and A1. So this is nothing but the address line. So these A0 and A1 are the address line which will specify that which port has to be used. So if your A0 and A1 is 00, so if your A0 and A1 is 00 address, so there you can access port A. Okay, so you can access port A. So now if you're having A0 1 and A1 0, so if you have A0 1 and A0 0, then you can access port B. Okay, so if your A0 is 0 and A1 is 1, then I have to make that particular use that particular port as port C. So next is control register. The control register is mainly used to program when we need to program that particular program that particular 8255. Okay, in which mode it has to use, whether it has to be used in mode 0 or mode 0 or mode 1 or mode 2. So that depends upon how which port has to be made use of. Okay, so now if you take the 8255, it's basically works in three different modes. Okay, so there is mode 0, mode 1, mode 2. So if you take the mode 0, so in the mode 0, all your ports will be acting as a simple input output port. Okay, all your port A, B, and C can be individually programmed as either input port or output port. Okay, that depends upon. I will tell you how when it will be used as an input port, when it will be used as a output port. So if you take the port ABC, so port ABC can be individually programmed as either input port or as either a output port. So if you take the port C, okay, in this port ABC, port C is exclusively split into 4 bit of each. Okay, you have it is divided into two 4-bit ports which are independent of one another. So port B is port C 4-bit upper, port C 4-bit lower. Totally these two are different. Okay, so those two ports can be used and you can access any of the devices or if you want to communicate with any of the outside world. So now when you are going to have this, when you are going to make the communication from the microprocessor to the outside world, so you are going to make use of the port mode 0. So you have to make use of the mode 0 itself. So your mode 1, so mode 1 is where port A and B are programmed as input and output ports, where your port C is used for handshaking. Normally these other two modes are not being used when you are using the IO operation. That means when you are performing the input output operation with respect to the outside world, so you are not going to make use of this. You are not going to make use of the other two ports, the modes. That is nothing but your mode 1 and the mode 2. So your mode 2 is nothing but bidirectional data transfer. So what do you mean by bidirectional data transfer? So your port A is programmed to be bidirectional and your port C is for handshaking, and port B can be either input or output in mode 0 or mode 1. So what you are going to have. Okay, so next when you are going to have this particular modes, different modes, so it is going to have basically, if you take 8255, it's going to work in two different modes. One is your bit set mode and other is IO mode. So in your bit set mode, so one is set, this particular mode is normally not used in most of the IO operations. So this particular mode is not, you are going to set or reset one bit. That's it, nothing else. So if you are going to have the bit so the bit set reset mode, so the control word will be used. So the control word will be of 8-bit. So the control word what you are going to have, it will be of 8-bit. So now when you are going to have the 8-bit control word, when you are going to have the 8-bit control word, so your D0 specifies whether if a D0 bit is 1, it is set. If D0 bit is 0, then it will be reset. So if D1 is, if the D1 bit is 0, so then it is going to select your B0, and if your B0 bit is 1, it's going to select B1. So next is D3. Okay, so D1, D2, D3. So this particular, depending upon these bits, it is going to select either B0, B1 or B2. So the totally 3 bits are dedicated to bit select. So bit select, so the number of combination, if you are going to have the 3 bits specified for that one is 8. That is, it will start from 000 to 111. Okay, so if it is going to have the 000, so it is not going to select any of the mode. So if it is 1000, so it is going to select B0. So then it is 010, B1 is selected, 110, both B1 and B1 is selected. If 001, only B2 is selected, B2 is selected. 101, B0 and B2 is selected. If it is 6, then it is B1 and B2 is selected. So if it is all is 1, so if all D1, D2, D3 is 1, then it is going to select B0, B1 and B2. Okay. So this is only for your reference. Okay. Even this is not as part of your syllabus. Okay. So now this is the part where you are going to have in part of your syllabus. Okay. So this is a control word format for IO mode. So this is very important for your examination point of view also. So now if we take the control word, so control word is mainly comprises of 8-bit. Okay, the control word is mainly comprises of 8-bit. So we have discussed, we have seen in your block diagram that it is going to be divided into two groups, right? Group A and Group B. So you can see it here, bit D0, D1, D2. Bit D0, D1, D2 corresponds to Group B. D0, D1, D2 corresponds to Group B. Whereas your bit D3, D4, D5, D6 corresponds to Group A. So you have to keep in your mind that we have shown in the block diagram that it's going to be have two groups. One is Group A, other is Group B. So now, if when you talk about the control word format, this is the format which is very, very important for your examination point of view. So your D0 is controlled by Group B. So in the Group B, what are the different ports it is going to use? So it is going to make use of port C lower. Port C lower is nothing but what I have told you that it's going to have 8-bit. So your port P is going to have 8-bit. So lower means PC0 to PC3. So that is what the lower it is going to tell. So next is port B. So if a port C lower, so if it is 1, so if I am going setting this particular bit to 1, that is D0 bit to 1, then your port C is acting as a input port. So if it is D0 is 0, then it will be acting as a output port. So input port is nothing but what? You are getting the input from the outside world. Output port is nothing but what? You are sending the output to the outside world. That is IO operation. That is input and output operation. So you have to configure, right? From which port you are going to access the input or which port you are going to send the output. Okay. So because same port cannot be used for both input and output. Different port will be used for input and different port will be used for output. Okay. So next is D1. So in the D1, what will happen if the bit 1 is set, if the bit in D1 bit is 1, then it will be treated as input port. If the bit in D1 is 0, then it will be treated as output port. So the mode selection, as I told you that, so if it is mode 0, then it is going to have normal input output port, because if you take the 8255, it is going to basically work in 3 modes, right? Mode 0, mode 1, mode 2. Normally, when you are doing the IO operation, always IO operation when you are using, it is going to make use of mode 0 only. So normally by default, when you are writing your control format, the mode setting for that particular mode setting will be always mode 0 by default. So by default, always the mode 0 will be the mode 0 only, it will be used for IO operation. So next is Group B. Group A. Okay. So when you talk about the Group A, so it's going to make use of port C upper. Port C upper means PC is going to make use of PC4 to PC7. So that is the bit which is going to have PC7, PC4 to PC7. It's going to make use of, through which your other devices will be connected. So either it may be an input device or it may be output device. That is how you are going to configure that particular port. So if you are configuring that particular port as 1, that will be getting the input, that will be acting as an input port. So that you are going to program your 8255 to act as an input port. So if I am going to set that particular bit to 0, so if I am setting that particular bit to 0, which is D3, so then it is treating as a output port. So now when you are going to have D4, D4 bit is used to program your port A. So in this one, port A, so if you are setting the bit to 1, then it will be treated as an input port. If you are setting the bit as 0, then it will be treated as output port. So your D5 and D6, D5 and D6, it is basically used for basically used for your mode selection. Okay. So if your D6 and D5 is 0, 0, then it is mode 0. If it is 0, 1, then it is mode 1. So if it is 1x, then it will be mode 0. Okay. So in which particular mode it is going to be used. So next is we're going to have the mode set flag. So in the, if it is set to 1, so then it will be active. So next, when you are going to have this particular configuration, how it will be done. So we have to have some So now, so we have to write the control word. Okay, so how to write the control word is the next question. This is important. Okay, so now here, as we have seen that, so we are going to have the bit 7 bits, right? 8 bits are there, right? So you are going to have the 8 bits. So that's I'm going to show you. So you're going to have the 8 bits. So D0, D1, D2, D3, D4, D5, D6, D7. So this will be D0, this will be D1, this will be D2, this will be D3, this will be D4, so this will be D5, this will be D6, D7. As we have seen that, so D0 you are basically used for port C lower. Okay, so if you want to make my port C to lower to be acting as, so normally it will be specified by PCL. So normally port C lower. So that means I am told you that it is going to have 8 bit. That is PC not to PC7 is going to have 8 bit. So it is on PC lower. PC lower stands for what? It will be taking the bits from PC not to PC3. So port C0 to port C3. So now this only these numbers it's going to have. So what this particular port number indicates that, so it's going to have from 0000 to 1111. So that means you can have the different 15 uh, 15 hardware can be connected for that particular ports. Okay, so that's what it suggests. So that is out of your syllabus now. So if you have the specific topic for that one in microprocessor, even you're studying 886, we would have explained that particular part. So but here it is now, you don't have to have that much depth in this particular part, because you don't have to program and you are not going to use your 886 processor. Okay, so now here when you're going to have bits, so it is going to treat that one as what? This particular bit PC lower. So if you are setting as 1, it will be acting as what? It will be acting as a input port. So if it is setting as 0, it will be acting as a output port. So if you are setting it to your B1, D1 is basically used for your port B. Okay, your D1 is used for your port B. Now your D2 is mode selection for mode selection for group B. So normally it is only 1 bit. So either it can have 0 or 1. So it is mode 0 or mode 1. So normally even your app, when you are working with respect to the mode 0 input output port, so you are going to make use of 0 only. So for IO operation, okay, for IO operation, so what will happen? So mode 0 is used. For IO operation, always the mode 0 is going to be used. So next, when it comes to the D3, so when it comes to the D3, so D3 is nothing but what? It's a port C upper. It's going to have port C upper. So what it suggests port C upper, it will be from PC4 to PC7. PC4 to PC7. So I can see that your port C lower is PC0 to PC3. Whereas your port C upper is PC4 to PC7. Whereas in your port B, it is going to have PB0 to PB7. Your PB0 to PB7. So yeah, similarly, you are going to have D3. For D3, it is going to have port C low upper. So port C upper refers what? PC4, it will refers to PCU. So it will refers to PC4 to PC7. Similarly, you are going to have D4. D4 refers to port A. So in the port A, if I am setting that particular bit to 0, that port A will be acting as a input port. Okay. So if I am setting that particular bit to 0, it is output port. So if I am setting it as 1, then it will be acting as a input port. Okay. So similarly, your D6 and D5 bit. So these 2 bits are used for mode selection. These 2 bits are used for mode selection. Okay. So if it is 00, mode 0. If it is 00, then it is going to select mode 0. If it is 01, then it is mode 1. Then it is 1x. Then it is going to select mode 2. So your bit D7, so always it will be 1 for IO mode. So for IO mode, always the bit D7 will be 1. Okay. So anybody having any doubt here in the bit representation? Which port has to be selected? Which port has to be made as an input port? Which port has to be used as an output port? And what are the different what are the different mode of operation you are going to have? which bit you have to use for mode selection for group B, and which bit you are going to make use of for mode selection of group A. So your D2 is used for mode selection with respect to group B. Your D6 and D5 is used for mode selection with respect to group A. Okay. So this one we have to explain. To understand this one, just I have shown the block diagram. That's it. So block diagram is not part of your syllabus. Okay. So it won't be a part of your syllabus, but only this part it is very important, where you have to configure your 8255 or program your 8255 to make as make to communicate through which port. Okay. So next, if you have any doubt here, anybody having any doubt? Anybody having any doubt here? Anybody having any doubt? Okay. So if you don't have any doubt, okay, we'll go further. Just I will give one statement here. Now here you can see it here. Let the control word be 89H. Then now the 8255 will be configured. So let us, they are going to tell that. So if my control word is 89H, so you are going to tell that control word is 89H. So if I am going to have 89H, they are going to tell you that how your 8255 is configured. So they may ask you in the question like this, is configured. Okay. So now 89H, if I represent with respect to the bit, how it will be represented? It will be 1, 0, 0, 0. It is 8. 9 is 1, 0, 0, 1. Anybody having any doubt? Anybody having any doubt? So given control word is 89H. So now, how is your 8255 is configured is the question. So configured is nothing but what? It is configured which port you are using it as an output port, which port you are using it as an input port, that you have to check it, right? So your control, it is defined by the control word. So control word will specify that which port you are using. So now this particular bit is D0. This is your D1. This will be your D2. Okay. And this particular bit will be D3. This particular bit will be D4. So this particular bit will be D5. This particular bit will be D6. This particular bit will be D7. Okay. So now, from your basic controller structure, which we have discussed previously, D0 refers to what? Which port D0 refers to? D0 refers to which port? D0 refers to port C. Okay. So now, port C lower. Your D0 refers to port C lower. Now, what is the value in D0? The value in D0 is here in this particular code word is 1. The value which is given for this particular code word is 1. So if it is 1, how your port C lower is acting as? So your port C lower is configured as input port. Your port C lower is configured as input port. Okay, so this is configured as input port. Now, next comes the question. Okay, how? So next is what D1. D1 refers to what? It is port B, right? So port B. D1 refers to port B. The value is the port B value is what? Value it is 0. So if it is 0, how it is configured? Whether it's input port or output port. If it is 0. If it is 0,
input.
No, for 0 it is output port. 1 it is input port. Don't confuse. 1 input, 0 output. Okay. So your port value is 0. Then it is configured as output port. Then it is configured as output port. Okay. So next your D2. So D2 specifies what? Mode selection. D2 specifies mode selection. The value in D2 is what? 0. The value in D2 is 0. So now, since it is 0, the mode of operation for group B is mode 0. Okay. So next, D3. So D3 bit is 1. So D3 bit is 1. For what your D3 is corresponds to which port? Your D3 corresponds to which port? Your D3 corresponds to port 3 upper. Your D3 corresponds to port C upper. Okay. So since the bit which is stored in D3 is 1, how your port C upper is acting as? Whether it's input port or output port. If it is a 1.
Input.
Yeah. So it will be acting as a input port. Okay. It will be acting as a input port. Okay. So now, even if we take the D4, so D4 bit is for port A. So your D4 bit is for port A. So what's the value which is stored in port A now? Value is 0 in this particular bit. So your port A is acting as what now? Whether it's input port or the output port. If it is 0, your port A is acting as output port. Okay. So now your D6 and D5. So your D6 and B5 specifies the mode of operation. So here, what is the value which is stored there? It is 0, 0. The value which is there in this particular control word is 0, 0. So if it is 0, 0, it is going to have mode 0. Okay. So your D7 is 1. So if it is 1, it is working in IO mode. It is working in IO mode. So this is how you have to configure. It has been configured with this particular control word. So now they may another way where how they are going to give is they may give you the scenario. Which are the ports I am making as an input port? Which are the port I am going to make it as an output port? Then you have to find the control word. Okay. So that is another way. So any doubt with this one now? Anybody having any doubt?
No, sir.
Okay. So now if you don't have any doubt, let us go further. Is the next part. So in the next question, you can see it here. So just so here you can see it here. So write the control word to configure the 8255 to interface 886 in IO mode. Okay, they will specify it is IO mode. So whenever it is going to IO mode, so our bit D7 will be 1. Okay. So such that how you have to configure the 8255, they are telling that you have to make port P to act as an input port, port A to act as an output port, port C upper to act as an input port, and port C lower to act as an output port. So otherwise, I will assume I will infer some other values only. So now assume that your 8255 is acting in IO mode. Okay. So I have to configure 8255 in such a way that so to make your port C lower to act as input port, port C lower to act as input port, your port C upper to act as input port, your port A to act as input port, and port B as output port. Okay, now I have to write the control word. So write the control word. Okay, write the control word. So that you should know how to write the control word. So control word will be written depending upon what? Your D0 to D7. Okay, control word you are going to have, as I told you, that control word is of 8 bit. Okay, so that will be D0, D1, D2, D3, D4, D5, D6, D7. Okay, so now your D0 corresponds to what? Port C lower. So now here in the statement, port C lower is acting as what port? Port C lower is acting as input port. So if it is input port, what's the value of D0 you are going to have? What's the value of D0 if it is acting as an input port?
1, sir.
Yeah. If it is acting as a input port, it will be 1. Now D1 corresponds to what? Port A or port B. Your D1 corresponds to port B. Okay. So your port B is acting as which port? According to the statement, your port B is acting as output port. So D1 is port B. So your port B is acting as output port. So the output port, the value is 0. If your port B is acting as a output port, then that particular port is treated as 0. So next your D2. So D2 is mode selection. Always IO mode, it is going to have mode 0 only. Mode 0. So this is for mode for group B. So mode for group B. So D3 represents what? Port C upper. Your D3 represents port C upper. So port C upper, what they have given to act as?
Input
What they have
port.
given? Port C upper is as input port. What is the value you are going to specify here now?
1.
Yeah, 1. So in port 3, port C upper, it will be treated as 1. So next is in D4. So D4 represents port A. So your D4 represents port A. Here port A is also acting as a input port. So then what is the value in that particular bit? In port A, what's the bit? 1. So your mode 0 only, since it is IO mode, what they are told. So if it is IO mode, always the IO mode will be for mode 0. So if you are going to have mode 0, IO mode, so it will be mode will be 0, 0. So your D6 will be 0, D5 will be 0. So since it is IO mode, your D7 will be 1. So since it is IO mode, it is operating. So it is not bit set reset mode. So that particular D7 will be 1. So now the control word becomes what now here for this one? If you bifurcate 4 bits, so this will be 9, this will be 9. So it will be 99H is the control word. So 99H will be the control word for the statement what they have given to make your port C lower to act as an input port, port C upper to act as an input port, port A to act as an input port, and port P to act as an output port. So the control word for this particular configuration is what? 99H. For that particular configuration, the control word what you are going to have is 99H. So anybody having any doubt? Anybody having any doubt here? So this is important. So like this only, you should know what is control word, structure of the control word, and how to solve this particular problem. So either of these two they will ask in the exam. Either the control word they may ask, or they may ask you the problem for 5 marks. Okay, so that is left to you. So how to write it by yourself, right? So this is important for your examination point of view. Anybody having any doubt? Anybody having any doubt? So it's easy. So only thing is you should know the control word properly and what value has to put for input port, what value has to be put for the output port. You should know that one. Anybody having any doubt now in this one? 8255. Anybody having any doubt? Anybody having any doubt?
No,
Huh? Yes?
no, sir.
Okay. So now you move further. That is part of your IO subsystem. So next, when you are going with the next topic, which is communication interface. Okay, the next topic which you are going to come is your communication interface. So whenever you are going to have the embedded system, okay. So what is the purpose of the communication interface in your embedded system? Okay, so when you want to communicate with the external world, so we have to communicate, right? So how the communication interface should be in my embedded system. So this whatever we are discussing is with respect to the embedded system, right? So the communication with respect to the embedded system. So when you talk about the communication with respect to the embedded system, you're going to have two different types of communication interface. One is your onboard communication interface. Onboard communication interface. Okay, communication interface. Next is external. Onboard is one, other one is external. So now your onboard is also called as device board. So if you take the onboard communication interface, so if you take the onboard, so onboard is also called as device board. Okay, so it is going to have device level or so device level communication interface it's going to tell. So similarly, your external interface is called as product level. So your external interface, external communication interface you are going to have. So this is normally called as product level. So this is called as product level interface you are going to have. Now, first is you're going to start with the onboard communication interface. So just I will brief it out. What are the thing it is going to have? So onboard communication interface. So in your onboard communication interface, so so this particular communication interface refers to what? So this particular onboard communication interface which you are going to have. So this particular communication interface. So this is going to have the different communication channels. Okay. So we are going to have the communication channels, different communication channel you are going to have. So whatever the different communication channels you are going to have, it is why it is used. It is used for interconnecting. So it is mainly used for the interconnecting the various ICs. Okay, it is going to be used for various ICs or peripheral devices. So it is mainly used for various interconnecting the various ICs and peripherals within the embedded system. So if you want to connect the different peripherals within the embedded system, it is mainly to be used. Okay, so this is why we are going to make use of the onboard communication interface. So it is nothing but we are want to make the communication. So communication inside your microprocessor or uh, inside your peripheral to the peripherals is normally going to happen with the help of the bus, right? You are going to have the bus. So with the help of the bus, you are going to communicate it. So now when you are going to have the communication interface, so what it is going to do? So the purpose of the communication interface is to connect. Okay, so it has to connect the various ICs which are there inside your embedded system, or if any peripherals are connected inside your embedded system, so it is going to be make use of that one. So some of the onboard interface which you are going to have is so I2C. So I2C stand for inter integrated circuit bus. So that is inter integrated circuit bus. Okay, so inter integrate. So next is SPI. So you're going to have the SPI. So where the SPI stands for serial peripheral interface. So serial peripheral interface, it is going to have serial peripheral interface bus. Okay, so serial peripheral interface bus you're going to have. So next you're going to have UART. So this you have been heard, I think. So that will be universal asynchronous receiver transmitter. So UART stands for universal asynchronous receiver transmitter. Okay, so next is your one wire interface you are going to have. One wire interface you are going to have. One wire interface. So next, the last one you are going to have is a parallel interface. So you are going to have onboard communication interface. It is mainly classified into 5. So one is first is your inter-integrated circuit. So inter-integrated circuit. Second is SPI. SPI stands for serial peripheral interface bus. Third one is universal asynchronous receiver. Fourth one is one wire interface. Fifth one is parallel interface. So these are the 5 different onboard communication interface which you are going to have. Okay. So now just I will brief it out what all this will be doing. So if you take the inter-integrated circuit bus, so it's normally if you take I square. So normally in your embedded system, most of the time they are going to make use of I square C only. So I square C is a onboard. So it is inter-integrated circuit. Okay, so it is an inter-integrated circuit which you are going to have. So now here in your integrated circuit, so as the name indicates I square C, so it is a synchronous. Okay, so this is nothing but what? It is a synchronous bidirectional. So it is synchronous bidirectional half duplex. So can anyone know what do you mean by half duplex? Bidirectional half duplex.
The communication takes place only in one direction.
Yeah, half duplex stands for what? The communication take place in only one direction. So at one in single instance of time, it will doing only one type of communication. In one direction, it is going to take the communication. So basically, this particular I square C. So Who developed this one? So it is developed by Philips. Okay. So it will be developed by Philips is the manufacturer of this particular communication interface, this type of onboard communication interface. So the main purpose of the onboard this I2C is to make a connection with the microprocessor and the peripheral chips in television system. Okay. So normally this I2C is used in TVs. It is mainly used in TV. Okay, in your television. So for what purpose it is used in your TV? So it is used in TV to make a connection used in TV. So used to connect between peripheral device used to connect between peripheral device and the microprocessor or microcontroller. Okay, used to connect the peripheral device and the microcontroller. So basically, this particular control lines which you are going to have, it's going to have two bus lines you are going to have, that I will tell tomorrow. So one is your STL, other is your SCL. Okay, so SDL stands for serial data. So SDL stands for serial data, where SCL stands for serial clock. Okay, so these are the two different bus lines we are going to have. So your SCL is normally clock. Why you are going to make use is, so clock is mainly used for synchronization purpose. Okay, for synchronization purpose you are going to make use of the clock, whereas your serial data line you are going to use for transmitting the serial data across the device. As the name indicates, serial, the data will be sent one bit after the other. So whatever the bit we are going to send here, it will be in terms of bits. So the bit which you are going to send here, it will be one by one, so one after the other. So now, so when you are connecting about the device with your I2C, so it is going to have two different types of devices. One is your master device, other is slave device. So I explain what you mean by master device and what you mean by slave device in the next class. Okay, so these are the things which you are going to have. So your I2C can be normally, so if you take the I2C, so the device connected to I2C. Okay, device connected to I2C can be act as either master device or slave device. Okay, so can be act as either master device or slave device. Okay, so we'll discuss about what you mean by master device and what is the purpose of the master device and what is the purpose of the slave device in your next class. Okay, so anybody having any doubt with your 8255, just go through the 8255 once and you see how to write the control word, what is the structure of the control word. So this is important for your examination point of view. So go through it once. Okay, so you have to go through what do you mean by control word. So how to write when you are given the control word, which port as acting as how the ports are configured, you should know how the ports are behaving, whether the ports are behaving as an output port or input port, that you should know. So after that one we discussed about the communication interface. So when you about that communication interface, there are two types of communication interface. One is your onboard, other is external. So when you talk about the onboard, we are going to have 5 different onboard communication interface as part of your syllabus. Okay, so there are a number of communication interface are there now. So the according to your syllabus, what you are going to have is your I2C is there, inter-integrated circuit. Second is serial peripheral interface, that is SPI bus. Third one is your universal asynchronous receiver transmitter. Fourth is one wire interface, and fifth one is parallel interface. Okay, so these are the several interfaces which you are going to have. Okay, so anybody having any doubt till now? So anybody having any doubt? So go through it once. So it was very important for examination point of view. Okay. So I will look into the master device and slave device with respect to your I2C square, I2C in tomorrow's class. Okay. So if you have any doubt, you can ask. So if you have any doubt, so you can ask the doubts. If you don't have a doubt,